in this exercise we are considering a dryer. So a dryer, it's an industrial setup that is used for many things, but used quite a lot, for example in the food industry. So in this example we have two successive operations that are done on a moist air. First we take moist air in ambient conditions, so at point number 1 the temperature is 20 degrees Celsius and the relative humidity is 50%. Then we know that this air is first heated. When it's heated we add some heat, but without changing the proportion of moisture and the proportion of humidity and from dry air. So X stays constant while the temperature is increasing. So the air is heated until a point that I have named point number 2, and then the second part of the process is that this hot air is sent over a product that we need to dry. So the product contains liquid water, and here this liquid water will evaporate until leaving the system at point 3, where the temperature measured is 21.6 degrees and the air is saturated. So the relative humidity in point 3 is 100%. So first, on the Carrier diagram, we can write the position of point 1 and point 3 because they are fully defined. Point 1 is at 20 degrees Celsius and a relative humidity of 50%, so point 1 is there. And point 3 is at 21.6 degrees, so just a little bit further on the x-axis, but we know that it's saturated, so it's over there. Between 1 and 2, the process of heating was done at constant moisture content. So from 1 to 2, the process was done with constant x, so this is X1, and it was heated, so the temperature was increasing, it was going to the right. But we don't know exactly where point 2 is. Then between point 2 and point 3 there has been evaporation of liquid water that has increased the moisture content of the air until being saturated. What happens in the drying process between 2 and 3 is very similar to what is happening with a wet bulb thermometer when measuring the state of a moist air using a 2 thermometer psychrometer. So we have seen in the lecture that this process of humidification of an air by evaporation of liquid water is a process that is taking place at constant enthalpy. So between 2 and 3 the enthalpy was constant. So you can look at the enthalpy here in the enthalpy line of point 3 and plot the isoenthalpy line from point 3, and we know that point 2 had the same enthalpy. So then the place where this isoenthalpy line and the iso moisture content line from point 1 are crossing defines exactly what is the state of point 2 between the two parts of the process. So then you can just read on the diagram the properties of point 2.